Let me tell you a story. It's September 10th, 2017, and you're a stormwater engineer for the city of Ormond Beach, which is that green dot in northern Florida on the map. In the days prior, Hurricane Irma, already the strongest hurricane ever measured over the open Atlantic, had raised devastation across the northern Caribbean, and now it's forecasted to move up the state towards your town. In the back of your mind, a 2009 unnamed storm event in which 20 inches of rain fell over 5 days, damaging 79 buildings and impairing access to the roads citizens needed to evacuate, is playing through your head. It was a traumatizing time, but your city and your town has rebuilt, and new upgrades have gone in. Hurricane Irma looks like something different, though, than this unnamed storm. The infrastructure you're responsible for is a 550-acre drainage basin, or area that collects water, of mostly single-family developments surrounding 5 interconnected lakes. Some of the upgrades that went in after 2009 involved adding 2 powerful variable frequency drive pumps to that discharge to Laurel Creek, blue line there at the top of the screen. You know that if you're able to run those pumps early enough when Laurel Creek isn't flooded itself, and that if everything goes according to plan, you can create 250 acre-feet, which is a lot of storage, of places to put water that would otherwise fill the homes and the roadways of your community. Moments of crisis stress all forms of management. Whether you're a hurricane or a stormwater manager with a hurricane coming towards your town, or a doctor with a patient's life on the line, situational awareness, knowing what to expect, is critical to effective decision making. What is the status of my stormwater infrastructure, is what you're thinking in this moment. What else do I need to do to prepare for this incoming event? And what of my existing resources can I start dedicating to the inevitable emergency response plan that's going to have to happen? Fortunately for you, one of the upgrades that you put in after 2009 was that you made Opti in charge of running those powerful pumps. And you know already that because Opti operates those pumps every time it rains, not just on these major hurricane events, that things are probably going to go okay, because you've seen the pumps running recently. And your teams have a culture where they expect these systems to be online and operating. So they have familiarity with what's about to happen. So when you signed into your dashboard on Opti's web portal, in the days leading up to that event, you weren't surprised, but you were very reassured. The first thing you saw was that Opti was aware of this storm and had already ordered automatically a drawdown event to reduce the water in those lakes and give your town the space to put the oncoming storm. You also were able to verify through the live information that everything had gone according to plan, and that you didn't need to spend more time thinking about how those pumps are going to work. You could go and deal with all the other problems that were headed your way. In the aftermath of that storm, the city did an analysis, and they determined that the intervention Opti made by drawing down that water predictively ahead of time caused or prevented the roadways, in this case, from being inundated, which would have complicated the evacuation procedure. The city also concluded in that analysis that had the storm actually tracked on its original path up the east side of the state rather than the west side of the state, if some of you remember how Hurricane Irma did something unusual, that millions of dollars of damages to the homes in your community was probably averted. But one well-functioning set of lakes in one storm does not a safe society create. My father actually had a saying that he used to like to tell me, which is that change is constant. And until you learn to embrace that fact and have a plan for adapting with it, you'll never be free from it, because you'll always be reacting to the things that it presents. He told me that because he wanted me to be a resilient person, somebody who is able to deal with new challenges in life and keep going towards the original direction. I'm telling you that now because I want us all to live in resilient cities cities that are able to deal with new, changing circumstances without much fanfare, and return to business as usual quickly after extreme events so that everyone can get on with their lives. Opti was built and founded by stormwater engineers and water engineers who were searching for a problem or a solution to a problem that had no existing solution. How do you make the stormwater systems of our world more resilient to the future that we see coming? A future that involves greater developed impervious areas, a future that doesn't necessarily always put new stormwater assets in place when new development occurs, a future that's experiencing more and more heavy rainfall events every year, a future that has a greater contentious level of debate around how public monies are dedicated to solving communal problems like flooding, and a future that, frankly, because of, even in spite of all the things I just said, is expecting the same level of service or better out of their existing assets because nobody wants to start living next to polluted water. How do you make that system resilient? The answer that we came up with is a process and a solution that we call CMAC, Continuous Monitoring and Adaptive Control. And simply it means taking a water level sensor and connecting it with a means of controlling when water stays and when water leaves from a storage asset, any stormwater storage asset, whether it's a pond or a detention facility or a cistern, and operating that system in line with pre-configured objectives about how that asset should behave in order to get more effective capacity out of the system. Opti is the only company in the world that's dedicated to this transformation of existing civil assets today, but we're hardly alone in our journey. When we look across the stormwater landscape, what we see is a very distributed amount of potential. Traditional stormwater interventions are motivated by events that make the news. Whether that was 40 years ago that caused regulations to create very one-size-fits-all type of rules about if I develop a certain size of apartment building, I need a certain amount of storage put in, or something more current and modern where you've got large discharge of sewage into lakes, something that the public can agree is distasteful and not in line with what they want. Either these ad hoc planned small units of storage are created or large projects that fit into the most developed, typically, areas of cities where storage is hard to locate, as Chicago recently did with their deep tunnel project, where they literally put a stormwater tunnel underneath the Chicago River at a cost of over $1 billion. Those are the ways that solutions to stormwater problems are typically developed today. Play video if you can. What Opti sees, though, when it looks across the stormwater landscape is a potential to address the issue upstream of these downstream confluence points by leveraging all of the different assets that are already in a city more collectively and with the potential to do so dynamically to achieve different performance objectives at different times. But that potential is very distributed. It's distributed spatially. You can't have a single monolithic solution that can be managed with a high overhead process. You need to be able to manage many of them with low overhead to achieve that kind of return. It's distributed in ownership. Not all of these assets are owned by the public or even necessarily traditional private landowners. So being able to validate that this asset is ready for the storm when you don't even have egress rights to check it out is a problem that stormwater managers traditionally don't have a solution for. It's distributed in availability. Sometimes these assets were put in place in response to a small specific regulation or rule, and changing their behavior is going to be a long human process to verify its safety. And for all those reasons, it's distributed in time. We're not going to necessarily achieve saturation in a watershed immediately. So our technology solutions, if that's what we're proposing, and that's what we are proposing, they need to be able to be upgraded and maintain their ability to deliver service over the lifetime that they'll be installed and over the lifetime it's going to take for us to get to significant capacity in the watershed. How many of you use a cell phone from 5 years ago? I mean, you have to update these as much as we update that technology. So what Opti is really doing, rather than necessarily just building this approach we call CMAC, is we're stewards for the digital enablement of stormwater management in our country. And we look at that in a very kind of multifaceted way. On that right side, you see a diagram. I call it the 7-layer dip of Opti technologies, because it's everything from the sensors in the ground to the cloud solutions that make them run. This digital enablement starts with insulation from technology change. Our value proposition begins with, it's going to take a layer of new technology for you to solve your stormwater management problem. I've yet to hear a stormwater management district ask for an IT challenge. One of the smartest things that we've done early on is partnered with Particle, which allows us to drop an application right onto a location with a cellular connection without having to have the IT department check a box about the new devices that are going to be running on their networks. Another thing that we do is we build only the parts in blue, and that has several implications. First of all, on site, all of the yellow parts are commercially available third-party components. And when we tell a municipality that we're going to take your assets and transform them into a digitally smart system, we're actually saying that you can unplug us, because most of the stuff is stuff you're already familiar with and stuff that you'll own. But it also means that we're on the hook to make sure that those parts continue working, because we license the blue parts to you as a service, and therefore are on the hook to make sure that your assets continue to perform as they were originally slated to perform in order to continue collecting that service fee. The other thing that's important about the strategy of not only running a service-oriented delivery of better stormwater management is that we have decided to, again, partnering with Particle, put our application on the site. And what that does is it helps us with what we call integration scope management. Basically, we can see both sides, the part in the cloud and the part on the site, and we're able to provide our customer success teams with better information about what might be going wrong with those integrated components, which helps delight our customers and builds trust in our solution over time, because we can get them back online faster because we're able to test things more closely to just seeing the end-to-end solution. Another piece that we've developed and probably is critical to introducing these solutions into the world is that we recognize and work with the human layers of the system that already exist. So we have this capacity to integrate civil authority with our new digital capability. Not all dynamic behaviors are safe for all civil contexts. And most of the time when a stormwater asset is created, a local jurisdiction has a professional engineer who's licensed there sign that in their professional opinion, this thing will convey water safely in all operating conditions. So the first thing that we do is we have a team of water resources engineers in our customer success team, which Tatiana will be telling you more about in a minute, who work with the customer and their professional engineers to understand what behaviors are off limits for this asset. And they're able to make sure that through our role-based access control system that those behaviors are not possible. Okay, so now the site engineer knows I've got a certain dynamic behavior I'm working with. What about when it fails? For that, we have another strategy, which is to simply set up effectively what we call a dead man's switch all the way down the stack to make it so that if any part above the one before it fails, they will all fail into a predetermined safe position. And that predetermined safe position, while not that imaginative technologically, you can imagine doing a lot more than that, provides that engineer with a single number that they can plug into their models about how this thing is going to convey water, which gives them the confidence to sign their name on the line. The other thing that we do is we recognize and embrace and don't necessarily criticize our customers for the fact that this idea of a performance-enhanced solution is not something they're already working with. They don't necessarily know where to put the control technology that we provide. They don't necessarily know what the ideal mixture of control and objective behaviors are that would work for them. So we provide a technology solution that can start as monitoring and be upgraded into control infrastructure down the line without losing that initial investment. We call this monitor and then control. So delivering IoT into the water space, the stormwater management space, First, it starts with understanding how the human layers of the system expect that system to behave, and making sure that we can create a solution that is in line with those expectations. To tell you a little bit more about that process for right-sizing a smart stormwater system, I'd like to give you Tatiana, who's from our water resources team.
Thanks, Alex. So as Alex has hinted at quite a bit so far, what Opti enables with a digitally enabled stormwater solution is fundamentally different from what's currently happening in the stormwater management process. Right now, or traditionally, a stormwater manager would identify a need in their community and identify a place where that need could be met. They'd then design that asset to meet those needs, meet the goals and regulations of that jurisdiction. Then they'd install it, and that's sort of it. Typically, we assume that infrastructure that we build continues to operate the way it was designed for a long period of time. That it operates the way it was designed at all, and then that it will continue to do so for a long period of time. There's really not this built-in idea of how is this performing day to day, year to year. And the lifetime of civil infrastructure is long. You can imagine that the environment around a new stormwater pond in a growing neighborhood changes drastically over 10 years even. And that's nothing in civil infrastructure, right? So when the environment changes, when the environment that the solution is installed in changes, what the community needs is for this asset to keep performing. But feedback is expensive, right? Feedback either comes in the form of adverse events that come to the attention of homeowners, flooding events make the news, this stuff is bad. And even if you're being proactive, getting feedback for what's happening at a system is expensive in terms of effort and manpower. You have to send someone out to take measurements when it rains and then when it's not raining anymore. None of this is simple or cheap. And that means that also changes to these systems in the long term are expensive. Changing how a system that's baked into the concrete operates takes time, it takes earthwork, it takes construction. None of those things are inexpensive. So what Opti does is Opti builds performance-based feedback into the entire life cycle of a stormwater asset. We're not just talking about minute-to-minute decisions, but also the entire life cycle from what kind of assets you identify through the design and installation and the continued lifetime of the asset. Adaptive capacity is the ability of a system to react to changes in its environment and to continue to make changes to operate the way it is intended to operate in the long term. So beginning with identification, having an adaptive solution means that we can fundamentally change how we think about identifying stormwater assets. In a typical system, you're really limited by what's the primary goal you're trying to meet. So here I have a flood control structure on top and a water quality structure on the bottom. You can see they look very different because they're trying to meet very different goals. The flood control structure will pass a lot of water, is really intended to control large storm events. The water quality structure is much more focused on controlling small to medium-sized events and preserving water quality. With Opti, instead of having the way that the site operates built into the concrete, we can dynamically control the outlet and use a single asset to meet more than one need. It also means that we can retrofit existing assets that were built for one purpose to more effectively meet that purpose and any additional needs that the community is experiencing. There are many places in the country where, for example, regulations are built around water quality, but we've seen increased high-intensity rainstorms, and we expect for that to continue, and what the community needs is both the water quality benefit and flood control. And by being able to dynamically control an asset, you can separate the opportunity for impact at an asset from the goals and regulations and have much more flexibility and new options. continuous monitoring and adaptive control also gives us the opportunity to affect how we design the assets to meet the goals that we're trying to meet. So I'd like to give you an example from Beckley, West Virginia. The city of Beckley, West Virginia has a road called Robert C. Byrd Drive, and during big rainstorms, that road, that intersection, would regularly flood. So in 2013, the city, in an effort to address this, found some land upstream and built a passive pond. So they put in this big investment, they built a bunch of upstream capacity, and it really helped. But they were still seeing flood events 2 to 3 times a year. So in 2017, they were looking to creatively address this problem. They evaluated several different options. Do they build new storage or new infrastructure elsewhere, or do they retrofit this existing asset with Opti? They chose to go with Opti, and then additionally, after collecting data across a series of storms over the next 4 months, the city said, well, we've done some analysis, and we think that we can almost double the capacity of this pond just by adding this. You see this green foam on top of that outlet structure. So by adding this piece of green high-density foam, they almost doubled the capacity of this pond to hold back water during rain events. And they were able to do this because they had the data to have confidence that this was a safe decision and that they really did have this capacity and that it would positively affect this asset's ability to meet its goals. This is a hugely different timescale from the traditional civil design process, right? This work was completed in a day. It took hardly nothing. And they told us, we adjusted how the software was configured, and then it operated with this new physical design. So I've talked a lot about identifying sites, designing them to operate in one way or another. And now I'm going to talk about, once you've decided to install Opti, what does that look like on a continued operation basis? For us, commissioning is a really critical point in time. We need to build trust for ourselves and for our customers that the water level they see on the dashboard is exactly the same as the water level that is actually in the pond, right? That when Opti says water level is just below the overflow, it really is just below the overflow. That when they manually control the valve through Opti, the valve will move. And so this is a point in time that we take very seriously. This is a big part of my job. And so we calibrate all the sensors, make sure that all the parts that we're integrating work correctly, and double check that the fail-safe state that we've agreed on, that the client has asked for, is what happens and still makes sense for this piece of infrastructure. So that if anything does go wrong, the valve will sit in a safe position until that can be resolved. Once the site's installed, then Opti goes into an optimization period. So at commissioning, we make sure that the measurements we're taking on site match physically with what's happening on site. During the optimization period, we make sure that the model that Opti is using to make decisions matches the watershed and the surrounding environment that affects how much water comes in or leaves the pond. A good example of this is the amount of runoff we expect. We don't always have the most up-to-date, the clearest information about exactly how much water will run off from into a particular pond. A lot changes, but when we're measuring, we can see, oh, well, we're seeing much less inflow each event than Opti predicted, or Opti isn't drawing down enough and we're seeing much more inflow. And by analyzing several rainfall events, we can then adjust the model Opti uses to best match the space it's using to make decisions with what's actually happening in the environment. Again, this is a step that you can't do in a traditional system because you've already baked these decisions in way down the line, and we can make these adjustments in software after it's been installed. And then we go into continued operation. Everything from sort of the most obvious thing we've talked about, over a single storm event, Opti can dynamically control the position of a valve to change how water moves through this point in space in a watershed to best meet that jurisdiction's goals. and it can operate differently in different size storms based on the predictions that Opti is making. We can also control this asset adaptively for maintenance needs, whether that's noticing that the pond draws down more and more slowly and maybe they should go check out some clogging, or if there's other things in the environment around this asset, we allow manual overrides so the stormwater manager can flip it into manual, close the valve, do some downstream work, all the while checking the water level, making sure that this pond stays in a safe state. Then once that work is done, they put it back into automatic and it continues working as normal. And then across seasons, the conditions, right, the environment that a particular asset exists in also changes from season to season depending on where it's located. Some places, base flow changes drastically throughout the year. Some places, ponds freeze over and we don't want to be trying to control them through the winter. So we can adjust and adapt, the system can adjust and adapt to different times of year. So I've talked a lot about the different kinds of adaptation that Opti enables in a stormwater asset, whether that's the goal that a particular asset is being used to address, exactly how it goes about addressing that. And all of this is possible at a rate that's so much faster than the traditional system, because we can make these changes in software, in how Opti predicts and reacts to rain events, instead of needing to get a backhoe on site and dig out 100,000 gallons of extra storage. That's a fundamental difference in the way that communities or stormwater managers for their communities interact with the assets they have and the investments they've made. Yeah, go ahead.
Nice. Thanks, Tatiana. So Opti is all about making sure that the expectations we have of reality are consistent with that reality. And as Tatiana just walked you through, there's lots of layers to doing that in the world of water management. But another piece of it that she relies on to do her job is that the technologies that Opti produces actually function in reality the way that she expects them to. And we've made some strides at getting that right over time. And to tell you about our latest effort in that regard, I'd like to bring on Austin Higgins-Cassidy, our new IoT engineer.
Quickly about the way we do IoT. So, Opti controls parts of a vertically integrated solution. There are a lot of third-party components and partner components in that solution. To succeed, we need to limit unexpected behavior from our own tools so that we can limit unexpected behavior in the entire stack. Now, Particle helps us with this by directly interfacing to those third-party devices to give us visibility into their unexpected behavior so that we can better control the system. IoT is a critical enabling ingredient of that, but it also pulls in a bunch of sources of change for us. Technological shift, 3G to 4G sunsets, business growth, new assets coming online, and our customer successes and failures. They want diagnostics. We need their feedback to improve our own systems. So the way we do this is by decoupling the Opti logic, which includes not only our application, but all of our platform management and processes. Using Particle as a platform that we can easily swap in, swap out, as well as OTA update, we can decouple from enduring technology, things that don't change, hardware protocols, Modbus, serial signaling, from shifting technology, things that are necessary but change rather rapidly. Cellular, LTE, Cat-M1, and our cloud API. This helps us to build in the opportunity to change wherever we need to into our platform without changing our core logic. So change is necessary, partially because technology shifts, but also because there are things like security patches and new paradigms of attacks coming out. Up here I have a little example of a vulnerability that occurred further up on the Particle stack that Particle quickly adopted into their new firmware. But we need to be able to move fast to capture that in our application. Of course, moving fast carries some risk with it. The more you change, the more you have to test. It increases your test surface. Additionally, we have a lot of specific knowledge about our product And it's very important that we don't invalidate that knowledge for our deployment engineers, since we send people out into the field to deal with these things. They need to know exactly what they're dealing with every time. So changing puts them at risk as well as my department. So part of changing with confidence is practicing defense in depth. We don't want to be complicit in our own failure, but we do need to expect it. How we do that is by limiting blast radius of disasters in production. This includes stuff like geographically fencing your rollouts. We have physical devices. It doesn't make sense to update all of them. We update a very small percentage that we can get to. A story where this went sort of horribly wrong is we updated recently Photon and Electron platforms. We ran Photon through all the tests. It passed with flying colors. The Electron had been previously tested. So we ratchet these builds into our deployment process, hit the deploy button, and watch as our electrons drop off the cloud one by one. The photons didn't. Now, we have a single logic. Whatever runs on our platform is the same code running on each platform with a minimal layer of changes to adapt it to the specific hardware. So we knew that something was up here with our builds. We were able to investigate quickly and trace it back to the fact that we had no kind of audit trail. We didn't know where those old Electron builds had come from, and they were faulty. We were able to devise a rollout strategy to downgrade quickly, and our deployment engineers were able to solve the problem within 24 hours, thanks to that geofencing that we had in place. But it is very important that we be able to change with confidence. Like I said, there was no audit trail for that build, and that's a big problem for us. Part of our defensive strategy is this write once, run everywhere strategy. But that really is write once, run on all your supported platforms, because you need confidence that it will run. You have to test it. You have to have done it before. It can't run everywhere. It can only run where you have run it. So enter Proteus. We've built a set of tools, a framework really, to aid testing on real hardware, on real platforms. The old way gave us a very minimal potential for audit, comments on GitHub, links to builds. The new method, using continuous integration systems that already exist, gives us a full trail from every commit to every binary that exists within our platform. Proteus is a testing platform. You can see it there on the right. As a developer, I want to be minimally involved in testing. I want to write my test once, make sure it's valid, and then I want it to be run by a machine every time. So, as a developer, I create a push, which goes up to GitHub, which then AppVeyor, the blue circle here, which is our continuous integration suite, takes that and kicks off an automated build of our binaries. Then Proteus, which is running on a series of small board computers, x86 PCs, or really any platform that supports Python, takes it, flashes real devices, runs through all of our integration test suites, and then runs through a set of things called test scenarios, which apply physical stimulus to the device, electrical signaling, serial input and output. It logs all of this, collates all the tests in JUnit, uploads them back to AppVeyor, where they are stored along with the build artifacts, and then, if it's a release build, pushes that same binary up to GitHub. This gives us not only a great deal of confidence in our builds, but a full audit trail. For every commit, I know exactly where that build came from. I know it underwent testing on every single one of our real physical platforms, and I know I can trust it. So Proteus is free and open source software licensed under the MIT license. We've built it to deal with our own test needs, but it's a very generic system that any test scenarios and integration tests can be built on top of. We use Spark unit tests, but Proteus will work with any unit test that produces output in a similar format. And since it's free and open source, can be extended easily to take input in any format you really need. We will be contributing bug fixes and building out Proteus with features that align with our internal needs. We have no full-time engineer on this. However, we will be looking at pull requests and issues logged on GitHub. So if anyone wants to make this better or fork it for your own use, we encourage you to do so. And look forward to your contributions. Thank you, and now I'll invite Alex and Titania back on stage for some Q&A.
Thanks. Sure.
Since you are dealing with civil infrastructure, have you run into any situations where you are recommending changes
kind of at a higher level. I wouldn't say that we are intervening at the kind of the local most resiliency code kind of level at the lowest jurisdiction, but I think regulators are taking notice of our solutions. Oftentimes we'll do things like put additional sensors into a watershed at our own cost so that we can show that the way that our control solutions work actually affects other objectives, so water quality being a big one. A lot of times people want to understand how nitrogen or other kinds of pollutants that come off the land are changed by the fact that we hold water back and allow natural processes like settling and bacterial digestion to start working on those nutrients. But measuring that's really expensive. So sometimes we'll fund that effort and then show the state regulators or EPA jurisdiction, or even just the national federal EPA, who has recently published a paper on how smart technologies like Opti could fit into the total portfolio of stormwater management solutions. We push kind of at the higher level in order to allow the propagation of regulation and rules to kind of affect the lower, kind of more local jurisdictions.
C person, you're like, wait, how much am I going to spend per year, per month for your service, and what am I really getting out of it? Is that like are you finding that that's pretty quick, or what are some techniques that you're using when talking to places like cities and things like that? Typically, like you mentioned, with declining budgets, that this is actually worth spending their limited dollar amount.
I think one big argument is that yes, they have to spend money on this, but it's much less money than potentially getting the same benefit from different kinds of solutions. Retrofitting an existing asset with Opti, even with recurring subscription costs, is a whole different scale in many cases from entering new earthwork, new construction, having to buy land, or even just do the earthwork itself to get new assets integrated. So the fact that we operate, some places we're included in new construction, but really a lot of places we're retrofit onto existing assets, and that's a really important way that we get in on the value proposition, and I think Alex can speak to it more.
Another thing that we've done is we don't just talk, we call them storm chasers, people who understand stormwater and know all the different ways they might want to change how it works. We recognize that there are individuals who are politically motivated to respond to the flooding events that are occurring and need to show progress in a meaningful way, even though, like Tatiana said, they don't have the budget to do a deep tunnel underneath their river at a cost of $1 billion. We also recognize that there's a growing amount of initiative at taking tech and applying it in the public space in a way that allows for visibility into the operations that everyone kind of participates in, but isn't necessarily recognized in their jobs. For example, even just knowing that a part needs to be replaced on one of these sites could mean that the flooding event that happens next month gets mitigated differently. And being able to have a digital picture that everyone in their jurisdiction can sign into and see that that they've all played a role in making this possible is a strong motivating factor that kind of stands outside the original need to control stormwater better. So I think there are lots of different angles to take, and it's just like any other sales process. You have to understand your audience and understand what motivates them to make decisions.
So we have time for one more question.
Sure.
So from what I understand, a lot of the value is from the displacement of water, like pre-storms and traditional deals of flooding and things of that nature. How about like passive water systems? Like we're touching on it, like it seems like they want to narrow that one study. How does that work in terms of like creating value in a way that there's not an ability to divert that water before it and don't feel confident with that?
Sure. So there's a couple kind of simple ones that I like to talk about. We call smart detention, basically a system that knows there isn't going to be rain coming in the next few days. I can hold that water back and allow what they call in wastewater treatment, primary treatment processes to take place. Most wastewater treatment plants are just the biggest chemistry set in the city, and they do very simple things. They keep bacteria happy so that that bacteria eats whatever pollution is in that water. And we can do something very similar simply by just keeping that water still and not necessarily discharging it downstream. But like Tatiana was pointing out, doing that is completely at odds with the idea of flood control, where you actually want to get the water out kind of as quickly as possible so that it doesn't back up in pool. So that dynamicism is one element. Another piece that we offer is we don't just say when the water stays and when it leaves, but how fast it goes when it does. And so you can imagine any asset acting almost like a rubber band to stretch the way that the peak of the storm kind of flows through the whole system. And what that does is it reduces the total amount of energy that's departed through the water downstream, which means that less sediment and other pollutants like dog poo and other things that are on the ground would get picked up and washed into public waterways. But it also means that you end up with less energy that causes beach erosion and other kinds of natural erosive processes that cost cities a lot of money on the back end, which they're already very aware of addressing and maintaining. Am I missing a major behavior?
And also ability to monitor. And maybe also to your question, we don't always install installations with a valve or a pump. There are many places where we enable people who have taken green infrastructure initiatives for their city to prove to stakeholders that those initiatives are making a difference. People ask for investment into new ideas like green infrastructure, and then they need to show that that's actually having an impact or that it's working the way they expect it to. So monitoring is also a big part of the value we can provide to municipalities or whatever stakeholder, because traditionally there's hardly any visibility into how these systems work except when they really don't work. So we're trying to get down into the quicker reactions. So I should go maintain this preemptively, or this is really working well, and the next time they do the budget, we'll get more money to do these kinds of interventions elsewhere. And that's another place where we can have an impact. All right.
Thanks, guys.